The first part of the process happens when the appointment is scheduled. And you've already seen our add new appointment method inside of the schedule aggregate root. So we're just adding a little more logic within that method and raising an appointment scheduled event. Now we have a service that's wired up to handle that event. That's called the Relay Appointment Scheduled service. And what that does is it takes in data that comes along with the event, which is appointment data, and it creates its own understanding of an appointment object using that data. Then it calls into our messaging logic and its publish method along with its appointment. And what publish does is talks to our message queue, which happens to be SQL Server Service Broker. And it takes that appointment, formats it as JSON, and inserts it into the queue. So before we go any further, we did just mention something new, which is message queues, and we just want to talk about that a little bit. It's a pretty advanced topic for this fundamentals course, so we're going to talk about it at pretty much a high level.
Yeah, message queues are nice to use between applications for a number of reasons. They can help decouple them and make it so that one of the applications can just drop off something into a message queue and continue on with its work and not have to worry about what happens to the message after that.
Right, or if whichever application or applications it's trying to communicate with, it doesn't need to worry if that application is available and listening at that very moment. The message can sit in the queue, and when the other application is ready to grab it, it does. With a message queue, we're really just dealing with a single message, and one application drops it, and the other one takes it, and then the message is gone.
Yeah, and there's lots of different implementations of message queues that you can find online. Some of them are free. Most of the cloud services that are out there now have these types of things built in as well.
What we're using in our demo is SQL Server's Service Broker, which is kind of, we like to think of it as the poor man's message queue. So you'll see us interacting with a service broker.
Yeah, some of the other ones that you can find online are RabbitMQ, MSMQ, which is built into Microsoft Server. Amazon Web Services has queues, as does Azure.
And what we're doing here is dealing with a single message at a time in something of a silo app, since we control both applications that are communicating with each other. But sometimes you need to have a lot more flexibility than that. You might actually have a number of applications that are interested in that message, and you may not even know in advance or control those applications. So this is when something called a service bus comes into play.
Right. So you'll frequently hear about something called an enterprise service bus, and there's, again, a number of examples of these that you can find available. And what the enterprise service bus does, it usually sits on top of message queues and other features. And one of the responsibilities it has is making sure that messages get delivered to the different applications that care about that message.
It might even be an application that didn't even exist or you didn't know about when you were first setting up the message queue. So even at that point, because Service Bus allows you to decouple the routing of the message, it's possible to go ahead and hook up other applications to listen to the queue.
Right, so you'll see in our scenario that we have our scheduling application raising an event that an appointment was created. And it might be that maybe in the future we would want to add some other application that wants to react to that event.
Like we can publish it to Facebook. Hey, I'm going to go see the vet.
Exactly. If we had a service bus, we could simply wire up in our service bus for this new Facebook notifier service to also pick up that event. But with just message queues, as you'll see in our implementation, we would have to change our scheduler application to know about this new app and write to its queue, because we don't have any advanced routing. Everything's hard-coded in our simple scenario.
We've got a list of some of the more common service buses, such as NService Bus. Azure has a service bus. Mass Transit and Mule are open source service buses, and Neudesic has one called Neuron ESB. Now, we also wanted to point out that Peter Ritchie has a great blog post on just an overview and comparing and contrasting using service buses and queues and brokers, and there's a bit.ly shortcut to that URL. So let's see what this looks like in the application. We'll go ahead and create a new appointment. Let's bring Samson in to see Dr. Jones again. So there's the appointment. Nothing has changed from the perspective of the user, but what's changed in the background is that now we have this message sitting in the queue. That got pushed into the queue. There's the message. It's just a string, JSON formatted. It shows the date and the time of the event and the client name, and there's more details. So that's sitting in a very specific queue that we set up for notifying users of appointments that have been scheduled, waiting for some other application to come and grab it.